ProCalc is a software application that allows users to easily develop and apply biomechanical models to their motion capture data. As ProCalc is wizard and graphics based, it means that users do not need to learn a scripting language to create their models. This video is an introduction to ProCalc and guides viewers through how they can navigate the software. All subsequent videos in this playlist will attempt to tackle specific biomechanical modeling questions or examples. To supplement this video, please ensure that you have downloaded the Vicon ProCalc product guide found at docs.vicon.com. This video will cover a few topics. I will first present the layout of ProCalc. I will then discuss the different calculation options and explain when each may be used. Lastly, we'll look at the options for running the model and how we can view our model outputs within our trial or session folder. When you first open ProCalc, you will see three main windows. The left window contains the controls for ProCalc. It allows you to choose what to process and how to process it. The top right window is the 3D workspace and allows you to visualize your markers and the current calculation. Lastly, the bottom right window is the output log, which displays the output of the selected calculation at the current frame where applicable. Looking back at the left window, you will see 5 tabs across the top. While you should be familiar with the data management from Nexus, the additional 4 tabs allow you to formulate your model. In order to access these tabs, though, you must have a C3D open. The first tab is for input parameters. An input parameter is typically any constant value. A couple examples of an input parameter would be a subject measurement or a known constant such as the value of pi. These input parameters can then be used in future calculations. The second tab is for variables. In ProCalc, variables refer to any time series data for which there are values calculated for each frame over a specified range. An example could be the left knee angles from foot strike to foot off. The third tab is for events. While this tab can help you to find and mark standard gait events such as foot strikes and foot offs, additional keyframes can be marked using more specialized criteria. These events can then be used for extracting data from other tabs. The last tab is for parameters. In ProCalc, parameters are discrete variable data that are calculated based upon identified events. An example could be maximum hip flexion during swing or foot velocity at ball contact. Each tab requires that you work within a scheme. A scheme allows you to save a set of elements that can be used when running your model. The drop-down menu provides access to previously saved schemes. To the right of this, there are options available for creating and/or managing an existing scheme. The plus icon allows you to create a new scheme. The pencil icon allows you to edit a previously saved scheme. The disk icon allows you to save your current scheme, and the red X allows you to delete the current scheme. Within any scheme, you have the option of specifying a base scheme. This means that the current scheme will reference any calculations made within that base scheme and can be used in current calculations. The remaining options allow you to undo or redo a step within your calculation, while export allows you to export your list of elements within that scheme, including their definition, to an Excel file. Within a scheme, you have 4 controls which allow you to either add an element to a scheme, remove an element from the scheme, copy an existing element, or mirror the existing element. I will provide an example of each control as we look into the different options within each scheme. Starting in the Input Parameters tab, I will go ahead and create a new scheme using the plus icon. I will type in example and then go ahead and add a new element. I will give this element a name, body mass, and it is actually a constant parameter that I am fortunate enough to have in my subject's model parameter file or MP file. So I changed the type from constant parameter to subject parameter. Under the subject measurements, I make sure to choose body mass and then I will click use. You can see that the value and the units were automatically populated. A description of the types of parameters found in this tab can be found on page 11 of the ProCalc product guide. Please pause the video now if you would like to review these input parameters in this video. One last option I have, and this applies to all elements within a scheme, is I can choose to annotate this element. So I can go ahead and type, this is my subject's body mass. And now when I hover my mouse over that element, it will go ahead and show me that annotation. In the Variables tab, I have already created the example scheme. When I add an element, it wants to associate a function. All functions are grouped into categories, and a list of functions and their definitions are available starting on page 15 of the ProCalc product guide. As there are multiple functions within a category, I will not post each definition here and ask you to refer to that guide. As a quick arbitrary example, I will calculate a vector from my right heel to toe. I'll first provide a name, so right foot vector. And then within my categories, I'll go ahead and select vector. And then within my list of available functions, I will select from point A to B. I can either use the drop-down menus beside each variable, or I can click directly on the marker within the workspace. So if I click on the right heel and on the right toe, when I finished adding in all the arguments, you can see the vector appear in the workspace. I can then choose whether I want all components or if I'd like to only include a subset. If I take only the XY components, this is effectively projecting this vector onto the floor plane. I will then need to specify a timing. As mentioned, variables are a time series, but you have the option of choosing when that time series begins and ends. These options are described on page 14 of the product guide. Please pause the video now if you would like to read them from this video. When necessary, you will also need to specify events based off of the timing option you have selected. There are only two options left. The first is if you want to negate any of the outputs, and the second is if you want to save this variable to the C3D. Please note that variables saved to the C3D may not appear in Nexus if it is not either a point or an angle. Now if I want to duplicate this vector, but for the left foot, I can simply highlight the element, click copy, and then below that click mirror. You can see that it has automatically changed the variable name to left foot vector as well as the markers from left heel to left toe. Please note that this name will only change if it is preceded by either left or right. The next tab is for events. Again, I've gone ahead and created my example scheme, and when I go ahead and add an element, you can see that I've got the 9 standard Nexus events available, but you can also choose a custom event. So I will choose a right custom event. I will give it a name, special, and then you will need to designate how you want this event triggered. So I will actually look at the right heel marker, so that'll be a point. I will select right heel, and I will only want to look in the vertical direction, so the Z. And I'll choose an arbitrary value for the threshold, let's say 50. So I want to know when that heel marker goes below 50, so down. And you can see in the time bar now, I've actually got my events designated there. And in the output down here in the bottom right, you can see that I've got the times at which those occur. If I add in another argument, let's say when this right heel marker, so the point right heel, when it passes, let's say the origin, I can choose in the X direction. You can see now I get a subset of that output, so just the last two values, as well as in the time bar, you can see that I've only got 2 events now. We will go into more detail in future videos about making more events. The last tab is for parameters. Again, I've specified my example scheme, and when I add an element, it wants me to choose from a category of functions. So in this example, I will look at finding the left ankle angle at each left foot strike. So my function is going to go ahead and be value, and my argument here is going to be variable A event A. I'll go ahead and give it a name as well, so I'll just call it left ankle angle at foot strike. So the variable that I want is actually going to be an Euler angle, and I'm going to select left ankle angle, and I'll look at every component of that angle, and then my input event is going to be at left foot strike. You can see that down in the output I've got both of the instances when a foot strike occurred, and as with other schemes, we will look into more complicated parameter schemes in future videos. Going back to the Data Management tab, I will show you a quick example of how to run this model. So I'll make sure that my example schemes are input in for each of the categories. I then will right-click on the trial that I want to process and select Mark. Down below I have the option of exporting the parameters, and I'm fine with putting it to the desktop and saving it with a file name of test, and also selecting the format, whether I want that to be an Excel sheet, a CSV, or tab delimited. I can then also choose whether or not I want to export the parameters as individual cycles, or if I just want an average and standard deviation. So I will choose to export it as individual cycles, and then I will click Process Mark Trials when I've got the correct settings. You can see in the bottom right in the log that it is going through each of the schemes. It's calculating the events, the parameters, and then writing that parameter to the Excel sheet. Now if I go ahead and reopen the trial in Nexus, you can see that I've actually got a new analysis output that's called left ankle angle at foot strike. And if I look at my desktop at the Excel sheet, you will see that I've got each of my parameter outputs for each cycle.
Thank you for watching this video. As always, if you have any questions about your hardware or software, please do not hesitate to contact us at support@vicon.com. Please also feel free to check out the links below for additional documentation and videos.